Welcome to Stat 282, Introduction to Statistics. In this video, we're going to talk about scatter plots, and then the correlation coefficient, Pearson correlation coefficient actually, which will tell us how likely it is that our data has a linear trend. So we have a scatter plot. By definition, the independent or explanatory variable is going to be along the x-axis, as we have down here. And then the dependent variable or response variable is going to be along the y-axis. And then for each little piece of data we have we're just going to put a dot on the graph. So we're going to look at three different data sets. This is one. We can see there's a pretty nice trend going from the bottom left to the upper right, so suggesting a positive linear trend. Whereas here, we don't see as much of a trend, but if we look a little bit more carefully, we see that in general, the lower numbers are toward the beginning and the upper numbers are toward the end, so maybe a bit of a trend there. Whereas the final scatter plot we're going to look at, it just looks like we have numbers all over the place. So, this first one, the one we had a good linear relation, I'm going to put a couple lines on here. First one, this vertical line, is going to show where the average is of the x values. And then this line is the average of the y values. And you'll notice here, if we were to make those our axes rather than the regular x and y axis, we have points in the first quadrant, we have points in the third quadrant, we have absolutely nothing in the second quadrant or the fourth quadrant. So that would suggest a pretty strong relationship. Now if we were to look at the second scatter plot we took a look at, the average there is a little bit different, so I'll put that line at that average. So we see 4 points in the second quadrant here, but the one's real close to the line. Also 4 points in the fourth quadrant, but again, we've got a point pretty close to the line there. We're not way off with this one. And we have several points in the third quadrant, several points in the first quadrant, so not as strong a relationship there, but we can at least reasonably say that there's a relationship. Then the third one, and we see plenty in the first or third quadrant, 4 points there, and none of them are really close to the line. Looks like we have 4 in the fourth quadrant, with the one being close to the line to being in the third quadrant, but the others are a pretty good distance away. And then got several in the first and third, but that point is more or less on the line. This point's a little bit above the line. The ones in the third quadrant are all not too far away from the line separating third quadrant with the second quadrant. So not as strong of a linear relation there. Now, there's a formula in your textbook for what's called the Pearson correlation coefficient. Well, if you needed to calculate a correlation coefficient by hand, absolutely you would use that formula. But it's the 21st century now. We don't need necessarily to use the formula. We have technology that will calculate a correlation coefficient for us. And it turns out that this one has a correlation coefficient of 0.9942. Whereas this one has a correlation coefficient of 0.4742. And this one has a correlation coefficient of 0.0734. So this one had the correlation coefficient of 0.9942, very close to 1. Turns out, as a consequence of the formula, Pearson correlation coefficient has to be between -1 and 1. And that tells us two things. One, it's going to have a sign on it. If it's positive, that suggests that we're going to have a line with a positive slope. If it's negative, it suggests we're going to have a line with a negative slope. So here, we'd clearly expect a line with a positive slope, and it was 0.9942. That's very close to 1, which is telling us there's a very strong possibility that there's a linear relation. Now this one has a correlation coefficient of 0.4742. Now it turns out there's a chart in your textbook. Modern statistical packages will give you a p-value. The chart in our textbook says a critical value for the correlation coefficient when n is equal to 20, we have 20 observations here, is 0.444. And here we had a correlation coefficient of 0.4742. So that is bigger than our critical value, so we're going to allow that to be a linear relation, but it's not exactly a strong one. And then we have here correlation coefficient of 0.0734. That is well below our critical value of 0.444, so we're going to say that there's not a linear relation here, or at least not a significant linear relation. So in class next time, we're actually going to take a look at the idea of, we talk about stuff being statistically significant, but what does it really mean for this correlation coefficient to be significant?